Hello, welcome to today's class. So today is our second class on macro preprocessor statements. In the last class, we discussed macro preprocessor statements, and we looked at statements that are used to change the flow of control. In today's class, we will look at expansion time variables and attributes of parameters. So expansion time variables are variables which can only be used during the expansion of macro. So when we have a macro call and we try to expand the macro call, during the expansion of the macro call, the preprocessor may use certain variables, and those variables are called expansion time variables. And we may have local expansion time variable or global expansion time variable. This is a concept similar to local and global variables in C programs. So your local expansion time variable is used only during a particular macro call, whereas global expansion time variables exist across all macro calls. These are the syntax for declaring local and global expansion time variables. So LCL is for local expansion time variable, and GBL is how we declare global expansion time variables. And these words are followed by EV specification. So in a particular statement, we may declare more than one expansion time variable. So if, for example, if we have two expansion time variables, we will need to use two EV specification. And the EV specification is ampersand followed by the name of the variable. And here is the example. Here we are declaring two local expansion time variables. The name of the variables are A and myvar, and as per the syntax, we include the ampersand sign in front of the variable names, and we are declaring them as local expansion time variables, so we use LCL. These variables can be assigned values using the set statement, and the syntax for the set statement is EV specification followed by set expression. An example for it is here. Here we are setting the value of the variable A to 1. So this is your EV specification, and then set and the set expression. Let us look at one example program. So in this program we have a macro definition and the main program, and in the macro definition we use local expansion time variable A, and that variable is, and then we have two set statements in this macro, and the first set statements changes the value of A to 1, and the second statement changes the value of A to A plus 1. So since A current value of A is 1, A plus 1 will give you the value 2, and hence A will be changed to 2. Now let us do a macro expansion for the given macro. This macro don't have any formal parameters, and hence it don't have any actual parameters, and hence we don't need to map. We don't need to do the mapping from formal parameter to actual parameters. We can directly try to do the macro expansion, and to do the macro expansion I copied the 6 statements here. Just for explanation purpose I'm copying it here. So we need to start at the line just after the macro prototype statement. This you already know. So when we expand a macro call, we need to use only statements after the macro prototype statement. So I copied those 6 statements here, and in today's class I am giving these numbers to the lines. That's because I want to introduce a new concept called macro expansion counter. We did not use macro expansion counter in the previous class, but I want to start using it from today's class. And macro expansion counter, the flow of control during macro expansion is implemented using the macro expansion counter. Since we need to start processing the macro starting at statement number 1, your MEC will be initialized to 1. So when MEC is 1, we means I will start processing statement number 1. And statement number 1 declares a local expansion time variable A. So when I process this statement, the variable A will be declared. No value has been assigned to A, so we don't know what the current value of A is. It's uninitialized. And this will complete the processing of this first line. And since this is a macro preprocessor statement, it will not appear in the expanded code. So I can remove this line, and since the first statement processing is complete, I will proceed to the second statement. So your MEC will change to 2 and the first line is removed. So MEC is 2, which means I will now process the second statement, and the second statement is also a preprocessor statement, and this is a set statement, set expression, and it will change the value of A to 1. So it's assigning the value 1 to A, and that completes the processing of this statement. So now I can move to statement number 3, and since the previous statement was a preprocessor statement, it was removed. And now statement number 3, we are defining a byte. So we are defining a constant, and here we are using the variable A, and since the current value of A is 1, and this will change to 1. And now this is a model statement, so model statement will appear in the expanded code, so I will not remove this line. And since the processing of statement number 3 is complete, I will proceed to statement number 4. So your MEC will become equal to 4. And now for statement number 4, again is a set statement, which is a preprocessor statement, and this is changing the value of A to A plus 1. And since the current value of A is 1, A plus 1 will be 1 plus 1, so this is 2. This will change the value of A to 2, and that completes the processing of statement number 4. So I can proceed to statement number 5. So MEC will become equal to 5, and this statement, because this is a preprocessor statement, will be removed. It will not appear in the expanded code. And now for statement number 5, it's again defining a byte. This is a model statement, and this variable will be replaced by 2, and that completes actually the processing of statement number 5. So we'll move to statement number 6, and statement number 6 is the macro end statement, and when I process it, that will be the end of the macro expansion. So the end, we are left with only 2 expanded statements. So now I can remove the macro definition, and I can remove the macro call, and in place of the macro call I can put these 2 statements, and this is my final code after the macro expansion is complete. So what the macro is doing is defining 2 new constant. The value of the constants are 1 and 2, and they are bytes. And with that I go to attributes of formal parameters. So attributes, the syntax for using the attributes of formal parameters is the attribute name apostrophe and the formal parameters, list of formal parameters, the formal parameter specification, actually not the list. And your attribute name can be T, or it can be L, or it can be S. T means the type, L means the length, and S means the size. It will be more clear through the example that I will use now. And in this example I have a macro definition, and then I have a main program, and in the macro definition I am using the attribute T of the formal parameter X. So basically I am checking the type of the formal parameter X, and this and we are checking whether the type of X is equal to B or not. B means the byte, and as you can see, this is actually a relational expression, so this will evaluate to either true or false. So if type of X is byte, so this will evaluate to true, and if it is true, I will jump to byte. So where is the sequencing symbol byte declared? It is declared in this statement. So if statement we have already studied in the previous class. So in the if statement, I am checking whether the type of the formal parameter is equal to byte or not, and if it is byte, that means this X, when the type of X is byte, this will evaluate to true, and if it is true, I will jump to byte. And if the type of X is not byte, this expression will evaluate to false. In that case, I will go to the next statement. I will not go to byte, I will go to the next statement. It will become more clear when I do the macro expansion. Let's proceed to do the macro expansion. And to do the macro expansion, I need to do the mapping of formal parameter to actual parameter. Here we have two formal parameters, X and Y, and two actual parameters, A and B. So the formal parameters are X and Y, the actual parameters are A and B, and since they are positional parameters, X will be mapped to A, Y will be mapped to B, and with this mapping I can proceed to do the macro expansion. And just like before, I am copying the statements just after the macro prototype statement, starting at the statement just after the macro prototype statement up to the macro end. These 6 statements I'm just copying it here. This is my mapping from formal parameter to actual parameter, and now I will use the macro expansion counter, initialize it to 1 because I want to start at statement number 1. And now I'll now do the processing of statement number 1. In statement number 1, I am checking the type of X, and X in this case is A. So I want to check the type of A, and A is declared in the main program as a byte. So the type of A is byte. So since A is byte, this relational expression will evaluate to true, and hence I will transfer the control to the place where byte is declared. Byte is declared here in statement number 4. So from statement number 1, I will jump to statement number 4, which means MEC will change to 4. And since I have jumped from A to 4, I have skipped these 2 lines. They can be removed along with the first statement. So these 3 statements can be removed. Statement 1 is already processed, and statement number 2 and 3, they are skipped because I jumped from 1 to 4. So these 3 lines I can remove. And in statement number 4, we have something called ANOP. ANOP stands for no operation. So when I process statement number 4, no operation will be performed. So nothing will happen when I process this line because it's no operation. And this is a preprocessor statement, so I can remove this line after processing. After processing, MEC will change to 5, and this statement is removed. And now I have a model statement, and in model statement I am using the formal parameter Y. Y is nothing but B, so Y will be replaced by B. And the processing of statement number 5 is complete, but this is a model statement, so I will preserve it in the expanded code. And then I go to statement number 6, which is the macro end statement, and when I process statement number 6, the expansion of the macro will be complete. So the end, I have only one statement in the expanded code. So now I can remove the macro definition, I can remove the macro call, and in place of the macro call I can put this expanded code, and this is the final code generated after the macro expansion. So what the macro call did is defined a new variable of type byte, actually a new constant of type byte, and the value of the constant is 25. Let us look at the same example, but this time let us use DW instead of DB. So the type of A is now word, it's not byte. And now, as before, let me try to perform the macro expansion. So we will initialize MEC to 1, and this time when I process the if statement, I check for the type of x is a, and this time a is declared as a word. So since the type of a is word, it is not equal to b, it's not equal to a byte, hence this expression will evaluate to false. And if it is false, I will not jump to byte. Instead, I will go to the next statement, statement number 2. So we'll jump to statement number 2. Hence, your MEC will change to 2. Earlier example, it changed to 4 because this relational expression was true, but this time it is false. So the relational expression is false. So I'll go to statement number 2, not 4. And that completes the processing of the first line, so I can remove it. This is the preprocessor statement, I can remove it. And now we will process statement number 2. Statement number 2 is a model statement, and here we are using the formal parameter y is nothing but b. So your y will be replaced by b, and that completes the processing of this line, and we'll proceed to the next line, next statement. So MEC is changed to 3. And this is again a preprocessor statement. This is the a go statement. This is like unconditional jump. So we will jump to the statement where the sequencing symbol over is declared. Sequencing symbol over is declared here, statement number 6. So we'll jump from statement number 3 to statement number 6. So your MEC will change from 3 to 6. And that completes the processing of this statement ego. So I can remove that line along with these two statements which are skipped. And now we'll process statement number 6, this is nothing but the macro end statement. And macro end, when we process this, the expansion of the macro will be finished, and at the end we are left with only one statement in the expanded code. So now I can remove the macro definition, I can remove the macro call, and in place of the macro call I can put the expanded code. The expanded code has only one statement, and this is our final code after macro expansion. So now we see that we declared a new constant of type word, and the value of the constant is 25. So this is how we can use the attributes of parameters. So in this example we used the type attribute of the parameter. With that we will go to conditional expansion. Conditional expansion are expansions. Conditional expansions are macro calls where we used macros where we use if and go statements. So the macros where we use if and go statements, in such macros conditional expansion takes place, and it helps in generating assembly code specifically suited to the parameters in a macro call. And when we have if and go statements, the statements are visited only under specific conditions. So when the condition is true, then only we will visit a particular statement, otherwise we'll skip it. So that kind of expansion are called conditional expansion. And actually we saw this example in the last class, where we used if and go statements. So this is an example from the previous class, and this is also an example of conditional macro expansion, where we are using if and go statements. So with that I'll stop for today's class. In the next class we will look at expansion time loops. Okay, thank you. If you have any questions, please post it through Piazza. Thank you.